Okay, so today we're going to be talking about the law of sines. Now we did this on Tuesday, but this is just a little bit of review if you're having some trouble with the homework. Take a look at this video. I'm going to go through finding a side, and I'm going to go through finding an angle. Now, before we move on here, the one thing you've got to remember, no matter what you actually call the sides and angles of your triangle, these capital letters in the formula, those represent angles, and the lowercase letters, those represent the sides. Now, it's very important that if we give them the same letter name in this formula, sine of b over b, that those are opposite angles in our triangle. So if we have a triangle here, if this is angle b, that is side b. Those have to be opposite in our triangle. Cross each other like that. So let's go ahead and take a look at the first example. We're going to be finding a side first, and then we'll move on to finding an angle. So we have a triangle here, and we're going to use the law of sines to find the missing side. We have two angles, 68 and 54, one side of 15 centimeters, and we're trying to find this side here that we don't know. One of the things you always want to look for to see if you can use the law of sines in a problem is if you know an angle and its opposite side. If you don't know at least one angle and a paired up version of its opposite side, like this problem here, then you can't use the law of sines, and maybe the law of cosines will be better off. So to start this off, I'm going to start by writing my law of sines up at the top of the page, just as a quick reminder. So I have the sine of A over A is going to equal the sine of B over B. Again, it doesn't matter what they're actually called as long as A and A are opposite from each other in your triangle. So in this case, I'm going to go ahead and use these as my A's. So 68 is going to be my angle A, and 15 is going to be my side A. And from there, we're just going to go ahead and start plugging things into our formula. That's the nice thing about this. We just plug it in. So we're going to have the sine of 68 degrees divided by 15 is going to equal, the other pair here is going to be our angle B. So 54 is our angle B, sine of 54. And the opposite side, which we are solving for, is going to be our side B. Now, if we look here, we just have a proportion, so we can cross multiply this just like any other proportion you've ever solved. We're going to start with this one, x times the sine of 68. We're just going to write as x times the sine of 68. And going the other way, that's going to equal 15 times the sine of 54 degrees. From there, we just have to keep in mind we're trying to solve for x. So since x is right there in our problem, we need to divide by the sine of 68 to get that equation solved for x. So we'll divide both sides by the sine of 68, divide by the sine of 68 on the other side. Remember, to algebra, sine of 68, it's just a number. We know in geometry, we know in trigonometry it has a meaning, but for our algebra purposes, it's just a number. We can divide like anything else. So now we have the equation x is equal to 15 sine of 54 divided by sine of 68. Now that's an exact answer. We could leave it like that if we weren't concerned with actually finding a number, but I want to know how far I have to cut to make this triangle or walk on the side of this triangle. So let's try to get this as an actual number. From here, we should just be able to type this straight into our calculator and get an answer. So let's give that a shot. We're going to type in 15 times the sine of 54. Make sure you close that parenthesis. If you don't close that parenthesis, it's not going to work. And then divided by the sine of 68. And if we type everything in correctly, we should get an answer here. So that would be 13.1 if we rounded to the nearest tenth, 13.1 centimeters. And that's all there is to finding a side. As long as you have the opposite angle and another pair, you can find a side using the law of sines. So next up, let's take a look at finding an angle. A lot of people find this a little bit harder, but it always starts the exact same way. We're going to start with the law of sines. And again, I'm just going to write it out. You don't have to do this every time, but I find it helpful just as a reminder. So the sine of A over A equals the sine of B over B. Look for your pair of sides that you know, or your side and your angle pair that you know. That's going to be A. So sine of 32 degrees over 5. and then the other side is going to be the pair that you don't know. So in this case, the angle is the one that we don't know. So that's going to be the sine of x over its opposite side, which is 8. From there, it's still just a proportion, so we're going to cross multiply and solve this thing. So 8 times the sine of 32 is going to equal 5 times the sine of x. Now, we keep in mind we're solving for x in this problem, and so we need to work our way back towards it. So the first thing we're going to do is to get rid of this 5 by dividing on both sides by the 5. And so that we have the equation now that the sine of x is equal to 8 times the sine of 32 divided by 5. And you could evaluate this with your calculator, but this is the sine of angle x. And just like when we were doing regular right triangle trigonometry, to find an angle, when we know its sine, we're going to use the inverse sine. And so we just have to tell the calculator, hey, I know the sine of this angle is 8 times the sine of 32 divided by 5. Plug that into the inverse sine on your calculator, and it's going to give you your angle. And again, just like with the last one, if you type this in exactly like that in your calculator, it will give you the right answer. Just be careful that you put those parentheses in exactly the same places. So we're going to type in the inverse sine